Okay, so now we're going to be solving a system of equations using something called the substitution method. And now the substitution method, what you are going to do is you are going to isolate one variable within one of your equations. Now I'm going to give you a little tip, like in number 1 and number 2. The easiest variable to isolate is a variable that has a coefficient of 1 or negative 1. Like, for example, in number 1, my x in my top equation has a coefficient of negative 1, so that's probably the easiest variable to isolate. In number 2, my y has in my top equation, my y has a coefficient of negative 1, so that's probably the easiest variable to isolate. Now, in number 3, my x in my top equation is already isolated for us, so that's good. And in number 4, my y in my top equation has a coefficient of 1, so that's probably the easiest variable to isolate. Now, there will come a time where you are given two equations and none of your variables have a coefficient of 1 or negative 1. So you would need to try to figure out which variable would be the best to isolate in that specific situation. But for right now, we're going to jump into the substitution method. So again, to start the substitution method, you want to isolate one variable within one of your equations, which we're going to start to do in number 1. I'm going to isolate x in my top equation by subtracting 2y. And now I have a negative x is equal to a 4 minus a 2y. And now I need to divide by a negative 1 to get x isolated. And I wind up with x is equal to a negative 4 plus a 2y. Now, since I know x equals that in my top equation, then I'm going to take that negative 4 plus 2y and I'm going to put it in for x in my other equation. So I have a 5 times a negative 4 plus 2y minus a 3y is equal to 1. So now this green equation is an equation that just has the variable y in it. So let's find y. I'm going to distribute the 5 into parentheses. Now I'm going to combine like terms. And now I'm going to solve for y by adding 20 to both sides. And dividing by 7 on both sides. I find out that y is equal to 3. Well, if you recall from our last lesson, the solution to a system of equations is an ordered pair, an x and a y value. I found the y value, now I need to find the x value. Well, what I can do is I can take this y value of 3 and I can put it into this x is equal to negative 4 plus 2y to get my x value. And I wind up with an x value of 2. So my ordered pair always comes x value first, then my y value. The intersection point between these two lines on the graph, if I were to graph these two lines, would be the point 2, 3. That is the solution to this system. And remember, you can always check your answer. So technically you can get 100% on these tests if you just check your answer and double check your work. All right, moving on to number 2. Again, step 1 is to isolate one variable in one of your equations. And remember, the y variable in my top equation was probably the easiest to isolate in number 2. So let's go ahead and let's start doing that. I'm going to subtract 5x from both sides. I wind up with a negative y is equal to a 1 minus 5x. And now I'm going to divide by negative 1 on both sides. I get y is equal to a negative 1 plus a 5x. All right, next, since y equals negative 1 plus 5x, let's put this negative 1 plus 5x in for y in my bottom equation, my other equation. So I have a 3x plus a 2 times a negative 1 plus 5x is equal to a 13. So I'm going to distribute this plus 2 in. Remember, if this was a minus 2, we'd have to distribute the whole minus 2 in. Don't forget about your algebra skills that we've learned previously. Then I'm going to combine like terms. I'm now going to add 2 to both sides. And divide by 13. I get x is equal to a 15 over 13. Doesn't come out nicely, but that's what x is. And now we are going to find the corresponding y value by putting the 15/13 in for x in this that I highlighted in green just now, or boxed in green. So I have a y is equal to a negative 1 plus a 5 times a 15/13, which is really a negative 1 plus, and you do the 5 times 15, which is a 75/13. And now a negative 1 can be rewritten as a negative 13 over 13, so we have a common denominator. And so now we just add the numerators together. So a negative 13 plus a 75 is a 62. So I wind up with y is a 62 over 13. So my ordered pair, x should always come first. 15/13, 62/13. That is my answer. All right, moving on to number 3. Remember, you want to isolate a variable, one variable, in one of your equations. Well, in number 3, we already have the variable x isolated in the top equation. So we don't have to do that first step that we've been doing for numbers 1 and 2. So I'm going to take this 5 minus y, and since it equals x, I'm going to put it in for x in my other equation. So I have a 2 times a 5 minus a y plus a 7y is equal to 0. I'm now going to distribute the 2 in. I have a 10 minus a 2y plus a 7y is equal to 0. Combining like terms, I have a 10 plus a 5y equals 0. Subtracting 10 from both sides, have a 5y is equal to a negative 10. And then dividing by 5 on both sides, y comes out to be a negative 2. Great. So I'm going to take that y value of negative 2, and I'm going to put it in to the x is equal to 5 minus y to find my corresponding x value. So I have x is equal to a 5 minus a negative 2, which is really the same thing as a 5 plus a 2, so x comes out to be 7. I write my answer as an ordered pair. This is where the two lines would intersect on the graph. X value comes first, y value comes second. The two lines would intersect at the point 7, negative 2 on the graph. All right, moving on to number 4. A reminder, step 1 is to isolate one variable in one of your equations. I'm going to isolate the variable y in my top equation. First, subtracting 4x from both sides. Oops, should be negative 4x, sorry. And then I'm going to add 8 to both sides. All right. So y is equal to a negative 4x plus 8. So I'm going to take this negative 4x plus 8. I'm going to put it in for y in my other equation. And it just so happened that in all of these equations, we isolated a variable in the top equation. That will not always be the case. Sometimes the easiest variable to isolate will be in your bottom equation. All right, so I wind up with a 5x plus a 3 times a negative 4x plus 8 minus a 3 is equal to 0. Distributing the plus 3 into parentheses, remember if that was a minus 3, you would have to distribute the minus sign as well. I wind up with all of that. Combining like terms. And now I'm going to solve for x. And x comes out to be positive 3. All right, I'm going to take that positive 3. I'm going to substitute it into this y is equal to negative 4x plus 8. And I'm going to find out what y is. Y comes out to be negative 4. I wind up with the ordered pair 3, negative 4. Now I want to mention that when we are putting our x value or y value back into this right here, you actually don't have to put it back into that equation. You can put your x or y value back into one of your original equations and you will find your other value that you need. It's up to you. The reason why I have been putting it into these equations that I isolated a variable in is because it's probably the easier equation to put your number back into. All right, that is the substitution method. So now we have one final method left, so please move on to lesson 3.